Hello and welcome to More Interesting Maths. I'm David Myers with UTC South Durham. In this series we are looking at GCSE mathematics. This is for those of you that want to revise for your summer exams, catch up on any materials that you may have missed, or if you're a parent that's wanting to help your kids out at home. Generic introduction clip over, now let's do some maths. So, if you've been following the videos as we've been bringing them out, then you'll have looked at factorising a single term and factorising quadratics. Today, we are actually going to look at one of my favourite little tools. I don't know why. Again, it's just a massive nerdy element of mine. Today, we're going to look at the difference of two squares. Loads of puzzles come out that tend to use the difference of two squares, and it's a tool that has stuck with me almost through university, spotting the difference of two squares, which can sometimes be a trick. Today we're going to look at it in a nice elemental form. Again, why I like it, I don't know, but I'm a massive nerd and I'm never going to apologise to you for that. The first thing you want to think about are the square roots of some of these more evil-looking variables, terms even. Let me use my terminology properly. It looks evil to begin with, and then once you've spent enough time looking at it, it's actually not as bad as you think. Because in the first instance, we're looking at, say, the square root of 4x squared. The square root of 4, what times by itself would give me 4? Well, that's 2. The square root of x squared, well, what times by itself gives me x squared? That would be x. So the square root of 4x squared is the combination of the two answers I've just given you, aka 2x. Similarly, square root of 25 is 5. The square root of y squared is y, so the square root of 25y squared, that's 5y. The square root of 16x squared y squared, the square root of 16 is 4, so the square root of this would be 4xy. X to the power of 4, y to the power of 4, it can seem a little trickier, it can seem a little bit daunting. What times by itself would give me x to the power of 4? Well, that's x squared. So x squared times x squared is x to the 4. Y squared times y squared is y to the 4, so the square root of x to the 4, y to the 4 would be x squared, y squared. Very hard to get that across verbally, and maybe I should make a few notes on it. If you do need or want any notes on that, do let me know in the comments. The square root of 9 is 3, and in a similar vein, the square root of, I'm just going to call it all this, the square root of all this squared is its original. As in, the square root of 9 is 3, and the square root of z minus 6 squared is z minus 6. You can stare at that for a long time, and I'm being deliberately vague about it. I don't want to go through all the working, because it serves to know what you're dealing with here is that the opposite, if you square a square root, or you square root a square, you get the original value. And I want to let that mystery just dangle with you for a little bit. Take your time to appreciate the kind of beauty that's occurring here. But when we have to deal with the difference of two squares, or factorising something like this, you can treat it as something x squared plus 4x plus 2 or whatever, and there are very advanced techniques that help you factorise something like this in its full form, when you have a full quadratic, as I've literally just called it. Loads of people are going to comment and say my terminology's all wrong there, and they are right, I admit. But I'm trying to show you a very nice and elegant little technique in here. How do we factorise something like 4x squared minus 9? You'll notice that we are looking at a square, and a square. 4 is a square number, x squared, by its definition, is a square value, and 9 is the square of 3. So let's see what we can do with that. We know that the square root of 4x squared is 2x, and we know that the square root of 9 is 3. So that very little trick that you've just watched is how we can factorise very, very elegantly that square function. I'll show you it again. 4x squared gets square rooted to 2x, 9 gets square rooted to 3, and you can put it in your brackets as quickly as that. 2x plus 3 times 2x minus 3. I'm not going to show you why it works. All I'm going to say to you is if you don't believe me, have a go at expanding those brackets down below. And you should notice that the x terms cancel out. You'll see a plus 6x and a minus 6x, and they will cancel each other right out. So, some quickfire examples. The square root of 1 is 1. The square root of x squared is x, so this will be 1 plus x times 1 minus x. Y squared minus 16, that The square root of that is y. The square root of that is 4. So we are looking at y plus 4 and y minus 4. The square root of x squared, y squared is xy. The square root of 9a squared is 3a. So we are looking at xy plus 3a, xy minus 3a. Square root of 25 is 5, and the square root of p squared is p. 5 plus p and 5 minus p. 4x squared minus 9y squared. Square root of 4x squared is 2x. The square root of 9y squared is 3y. No surprises, no tricks. 2x plus 3y and 2x minus 3y. All you need for this very, very elegant little algebraic trick is to be able to square root something, which I think is really quite elegant. Have a go at testing your understanding. I am going to, however, assume that you've paused the video to see if you can do it for yourself at home. So I'll start you straight off. That should square root to give us x. This will square root to give us a 6. We are looking at x plus 6 and x minus 6. Following swiftly on, we are looking at the square root of this, which is y, and the square root of 49, which is 7. Y plus 7 and y minus 7. Square root of 4 is 2. Square root of 9x squared is 3x. 2 plus 3x and 2 minus 3x. And finally, we would be looking at 1 minus 2pq. 1 plus 2pq and 1 minus 2pq. I really think it's a very elegant factorising tool. It doesn't always work, but when you find yourself looking at a load of square values, you can factorise it as easily as that. Extension challenge questions. These are always a little bit interesting, and I do notice that half of the brackets been missing here. How can we deal with this in quite a nice way? It is worth looking into. X plus 1 squared take away x minus 1 squared. It's tempting to think that that's going to take us an age. It's incredibly tempting to think, God, we've got to expand all the brackets, we've got to see what's going on in this weird form, then we've got to simplify it all. You can. You can expand all the brackets, you can simplify it. Here's a lovely little elegant trick for you. Yeah, I appreciate it. I'm probably not being loved at the minute. Because they are squared terms, the square root of x plus 1 all squared is x plus 1. The square root of x minus 1 squared is x minus 1. So we can put that into the brackets. You've got to take it very carefully here. But this will become x plus 1 plus x minus 1 plus x plus times by... I'm going to start that again. Square root of this, square root of this. X plus 1, x minus 1. This plus this, so x plus 1 plus x minus 1, all times by x plus 1, take away x minus 1. Take your time with that. Draw it out for yourself. This all here on the left, x plus x is 2x, and 1 take away 1 is nothing, so we are looking at 2x times, what's all this over here? X take away x is going to be nothing. 1 take away negative 1, that's 2. This becomes 2x times 2, which is 4x. Have a look at that up top. This really awful set of brackets turns out to be nothing more than 4x. What about 49 take away 1 minus x all squared? Same trick. Square root of 49 is 7. Square root of this is 1 minus x. So this will become 7 plus 1 minus x, and 7 take away 1 minus x. 7 plus 1 is 8, minus x over on the left, and 7 take away 1 is 6. We're taking away a negative x, so it becomes a positive x. This is the bit where I really kind of like it, this bit on 51 minus 49 squared. Because again, it looks awful. But what we're actually looking at is some square values. So this is the same as 51 plus 49 times 51 minus 49. 51 plus 49 is 100. 51 minus 49 will be 2. So the answer is 200. 51 squared minus 49 squared, 200. You don't have to square the values. You don't have to multiply them or anything. It's there straight away. In using a complicated technique, we actually make the maths a lot easier to do for ourselves. Yes, you can do it with your calculator if you really insist. Me personally, I think it's just elegant that it sits right there waiting for you. And finally, we've used the same technique in here. What you've got to remember is that the square root of 9 is 3, so we've combined these techniques. 2t plus 1 plus 3 lots of t minus 6. And if you try that in a written format, then you will get the correct answer. But please, I'm not going to go into that too much because that's an incredibly elegant technique. And for those of you that have just learned about the difference of two squares, I don't want you overtaxing it. I've already overtaxed you with the extension material. Again, as always, I'm going to make myself vanish. I'll reveal the odd questions first. Have a go at it for yourselves and see how you do at home. And there you have it, ladies and gents. One of my favourite tricks, finding the difference of two squares. For most of you, I'm anticipating at home that questions 1 through probably about 7 weren't too bad. Questions 8 and thereafter are just mind-blowing things. Do have a read through some of the questions later on and see how you feel about it. Otherwise, well done. And that is it for this video, ladies and gentlemen. Thank you so much for watching. If you think it helped you out with your maths revision at home, then please click subscribe to get notifications on future videos. Share it with a friend if you think it will help them as well. There is a PayPal account, but please don't feel obligated to do that. 10 or 12 pence if you think that it's worth it for you at home and you liked the video and the content that I've put out. Failing that, thank you so much to Dr. Frost Maths for the slides, for UTC South Durham for inspiring these videos, and most importantly to you at home for watching. I'm David Myers. Take care.